Alright, welcome back for another video. Today we're going to look at exponent laws. Just a couple of laws actually. We're going to look at the what happens when we multiply powers. So first, if we've got 3's multiplied by 3, so 3 times 3 times 3 and 3 times 3, we could express those as powers. A repeated multiplication of 3 3's would be 3 cubed, 2 3's would be 3 squared, and the resulting 5 3's would be 3 to the power of 5. So what can we do with these 3 cubed and 3 squared to have it equal 3 to the 5? Well, the bases are the same, 3 and 3, so we can add the exponents. 3 to the 3 plus 2 is equal to 3 to the 5. Same thing with these 4's. I can see this is going a little fast. 4 to the 7 and 4 cubed. We add the 7 and the 3 to get 4 to the 10. Negative 3 to the 2 and negative 3 to the 4. We add the 2 and the 4 to get negative 3 to the 6. Now careful here, if there's a negative sign out in front, that doesn't affect anything. My bases are the 2's. The negative comes out in front. I'm going to get 2 to the 3 plus 5, which gives me negative 2 to the 8. So when multiplying powers, we add the exponents. Note that the bases must be the same. Alright, that was nice and quick. Now let's look at division. Oh, and here's a general statement for that exponent law. Dividing powers. If I have something like 3 times 3 times 3 5 times divided by 3 times 3 times 3, we know that the 3's can cancel. So a 3 on top, 3 on the bottom, cancels out, becomes 1, etc. That leaves me with 2 3's on top, which is equal to 9. If we use exponent laws, we can say that 3 to the 5 over 3 to the power of 3 is also equal to 3 to the power of 2. Now how is that possible? Well, to get to the 2 from a 5 and a 3, we subtract the exponents. So 3 to the 5 minus 3 is equal to 3 squared. When we divide powers, we subtract the exponents. So as long as the bases are the same, and as long as I guess the base isn't 0, you can subtract the exponents. So a to the m over a to the n is equal to a to the m minus n. 4 to the 26 over 4 to the 15 equals 4 to the 26 minus 15, or 4 to the 11. Big number, by the way. Alright, so I don't think we're putting any examples there. There we go. Third law. Power of a power this time. So if I've got 3 times 3 times 3 multiplied by 3 times 3 times 3, we've got a repeated multiplication. That's like saying 3 to the power of 3 times itself. Just like 4 times 4 is equal to 4 squared, this is 3 cubed times 3 cubed, or 3 cubed squared. If I look at all those 3's, I've got 6 3's up there. So that's like saying 3 to the 6, or 3 to the 3 times 2. So I multiplied the exponents to get my power. So 5 to the 4 to the power of 2 would be 5 to the 4 times 2, or 5 to the 8. So the power of a power law says that a to the power of m raised to the power of n is equal to a to the m times n, or a to the mn. 2 to the power of 3 raised to the power of 4. A little jump there in the data, sorry about that. There's some other examples, though. You can see 3 raised to the power of 3 and 2, so 3 times 2 is 6. 5 to the power of 4 raised to the 2 is 5 to the power of 8. In purple here, 2 cubed raised to the power of 4 times 2 to the 6. Well, let's deal with this exponent first. 2 to the 3 times 4, or 2 to the 12. And then times 2 to the 6. Now we add the exponents, and we get 12 plus 6 is 2 to the 18. A little bit more involved here. 5 to the 10 and 5 to the 8 over 5 squared to the power of 6 and 5 cubed. The line, that sort of fraction line, is like a grouping symbol. So I deal with what's on top and I deal with what's on bottom, and I treat them separately until I've simplified the top and simplified the bottom. So 5 to the 10 and 5 to the 8, they have the same bases. They're being multiplied, so I can add the exponents. 5 to the 18. Down below, the 2 and the 6 get multiplied to give 5 to the 12, and the 12 plus 3 add to get 5 to the 15. Now I divide the powers, so I subtract the exponents, and then I can evaluate. So 18 minus 15 is 3, and 5 to the 3 is 125. So I know that this video lesson is quick, but you can go back and take a listen to it again. The assignment on page 64, section 2.4 is number 3 and 4, all of them, I think. 5 ACE, I believe, yeah. And let's put in 7 and 9, some multiple choice questions, 7, 8, and 9. And then 16 and 17.